In this video, we will explore how to use the z-distribution table to determine probabilities associated with the standard normal distribution and apply this knowledge to solve normal distribution probability problems. A z-distribution table, also known as a standard normal table or z-score table, is built on the standard normal distribution, which has a mean of 0 and a standard deviation of 1. In the z-table, the header column shows the ones and tenths place of the z-score, while the header row shows the hundredths place. Each value within the table itself represents the cumulative probability, that is the area under the curve, up to that specific z-score. Any normal distribution can be transformed into a standard normal distribution using z-score formula, which represents how many standard deviations a particular data point is away from the mean. Now let's say you want to find the probability of getting a value less than 1.36 in a standard normal distribution. This corresponds to the area under the curve to the left of 1.36, also known as the left tail probability. To find this using the z-table, locate the row for z equals 1.3 and the column for z equals 0.06. The value at the intersection of this row and column is your left tail probability. This value represents the proportion or percentage of data falling below 1.36 in a standard normal distribution. In this case, the left tail probability is approximately 0.9131 or 91.31%. Now, suppose you want to find the probability of exceeding 1.36 in a standard normal distribution. This represents a right tail probability, or the area under the curve to the right of 1.36. To find this, you can use the left tail probability we just calculated and then simply subtract it from 1. In this case, the right tail probability is approximately 0.0869 or 8.69%. Sometimes, you're interested in finding the probability that a standard normal random variable falls between two specific z-scores. This is referred to as a two-tailed problem. To solve this, you first find the left tail probabilities associated with each of the two z-scores using the z-table. Then, you subtract the smaller left tail probability from the larger one to get the desired probability between the two z-scores. Thanks for watching. If you found this tutorial helpful, please like and subscribe for more statistics content.